Hey friends, my name is Z and you're watching the Makes It Easy, and welcome to a new video for IGCSE App Maths. And today we have rules and examples for permutations and combinations, or perms and coms, and we'll look into the questions in next lesson. But here's rules and examples, starting with some basics. And before you get into it, don't forget to leave a like, subscribe, and ring the notification bell so that you don't miss out on any future videos. And we'll get right into some basics. So here we have three basic counting principles right here. So number one, we have m times n. So basically these counting principles are a way to find the possibilities or how to count different things. So m times n is a way to find a configuration of something. So when to use m times n is that when you have this example right here, 6 men and 5 women in a mixed double competition, how many pairs are possible? You would just do 6 times 5 because it's the basic counting principle, and 6 times 5 is it's a way to find how many mixed double pairs are available. So that's number one, and we don't typically use it, but it's still something that we would use. And number two, we have a to the power of b, and basically a is how many ways to do something, and the power, the b, is how many of something. So for example, there are 4 spaces to fill and 5 choice for each, and the fundamental counting principle gives us basically how to find it, or how to solve this question, is you would do 5 to the power of 4. Because it says there are 4 spaces to fill, so there are 4 something to fill, 1, 2, 3, 4, and there's 5 choice for each. So there's 5 ways to do something. So there's 5 ways to fill this, 5 ways to fill this, 5 ways to fill this, and 5 ways to fill this, and you times them all together, which is basically 5 to the power of 4, which is 4, which is right here, 5 to the power of 4 and 5 to the power of 4, right here. And number 3, we have n to n factorial, and we'll look into this later, the factorial sign. But basically, n factorial is used when you're trying to arrange different things without any condition. So how many ways to arrange 5 people in a row? It'll be 5 factorial. Because what this is that, let's say we have 5 seats, 1, 2, 3, 4, 5. Let's say you have 5 people, right? So in the first seat, you can arrange 5 people because there's originally 5 people. So 5 people can be fitted here. Times by the second seat. Since one person has already sat in the first seat, the second seat can only be set by 4 people. So times by 4. And the third seat, since the first 2 seats has been taken, the third seat can only have 3 people. 3, so the same logic, times 2, times 1. And this is basically a factorial, which is 5 factorial. And we'll look into what factorial means. So we have n factorial, where n is just like a number, it could be 5 factorial, 6 factorial, it's like a constant. So what factorial means is that when we have n factorial, it'll be equal to n times n minus 1 times n minus 2 times n minus 3, indefinitely, so n minus something, let's say a. So what this means is that if we have 5 factorial, it'll be 5 times 5 minus 1 times 5 minus 2 times 5 minus 3 until it reaches 5 minus 4, because you can't have 0, because if you times everything by 0, it'll be 0, so you can't reach 5 minus 5. So this means that a has to be bigger than n, and it's not equal to. So a more straightforward way to know this is that when you have 5 factorial, you basically are multiplying the number 5 by descending order to 1. So it'll be 5 times 4 times 3 times 2 times 1. And 8 factorial will be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And using this logic, you can also know that 8 factorial is equal to 8 times 7 times 6 times 5 factorial. Because 5 factorial is this part right here. This part. And basically this is what I meant from here. So one key thing to note is that 0 factorial is equal to 1. and there's some proof for that, but we won't get into those proof right now. But you can just search it on YouTube for the proof that 0 factorial is equal to 1. Then we have permutations and combinations. And for permutations, it's basically written as n, like p and r, where n is a superscript and r is a subscript. So it could be like 5p3 like this. And permutation is when the order matters. Order matters. And combinations is when order doesn't matter. So what I mean is that when we have, like, let's say Q and R, let's say they have both like different people, Q and R, when they're lining up on like a queue, for permutation, Q and R will not be the same as R and Q. So the first person being in front of the second person is not the same as the second person being in front of the first person. However, in combinations, the order doesn't matter. That means that QR is equal to R and Q. So the first person in front of the second person is the same as the second person in front of the first person, and they're both the same. And for both permutations and combinations, one key thing to note is that the subscript, the R, has to be smaller than or equal to n. Because, let's say, 5p4, it's correct, it's true. 5p5, it's true. But 5p6, the R is bigger than the n, so it's incorrect. I mean, you can't get an answer for that. So for the permutations, the equation is basically n factorial over n minus r factorial as mentioned. So it could be, let's say, if it's 5p3, it'll be n is basically the subscript, so it's the superscript, 5 factorial, over 5 minus 3 factorial, and you could simplify that. And furthermore, there's a button in your calculator that you can use to calculate the permutations and combinations. So I have the Casio, this Casio silver calculator with me. So if you look at the right hand side, above the times and divide button, there's NPR and NCR. And if you type shift, then you put the times button, you get a P. So it depends what calculator you have, and you have to try it around. But anyways, for combinations, the equation is quite similar, but there's something different. There's R factorial. Specifically, the equation for combination is n factorial over n minus r factorial. So let's say it's 5c3. It'll be 5 factorial over 5 minus 3 factorial times by 3 factorial. Like so. Oops. Like so, factorial. And now we move on to some more basics. So here's just a diagram to show you the whole permutations and combinations without restrictions. And so let's say we have n, and we have permutation ordered and combination unordered. You can see the different ways to do it. And now we move on to some examples. So number 1, calculate 8p5. So I could just type into my calculator, but I'll just write the whole thing out for this video. So 8p5 would be 8 over 8 minus 5 factorial, 8 factorial here. So 8 factorial, that means it will be 8 factorial times 3 factorial. And if you cancel out the 3 factorial with the top factorial, you're left with 8 times 7 times 6 times 5 times 4. Like so, because you cancel out the 3 factorial. So if you type into calculate 8 times 7 times 6 times 5 times 4, you get the answer, which is 6,720. So it'll be 6,720. So question number 2, we have 4 boys and 5 girls. How many ways to arrange them when the first 2 have to be girls? So let's just draw like a queue, like different lines to represent all of the members. So in total there will be 9 people. So like 1, 2, 3, 4, 5, 6, 7, 8, 9. So the first 2 have to be girls. So let's just draw like a box within the first 2, like so. So the number of girls present in the queue, there's 5 girls, and the first 2 have to be girls. So we have to somehow put 5 girls into 2 girls right here, like to find the permutation or the combination. So the first choice is that you can put 5 girls right here, and after putting 5 girls, you have 4 girls left. So you have to times by 4 girls. And that's it because, and that's basically 5p4. So 5p4, 5 times 4. And once you've like put the two possibility for like the first 2 seats, you can just rearrange the rest by themselves. So once you have taken 2 girls in the first 2 seats, there'll be 3 girls left. 3 girls. So it'll be 4 boys plus 3 girls, which is 7 people in total. And from the basic counting principles, one of the counting principles is 7 like n factorial. When you use it when you're trying to arrange people on like a line or a queue. And in this case, it's the same. So it'll be 7 factorial. And since 7 factorial means that you're rearranging 7 people on 7 seats, like for 7 different seats, it will be appropriate in this case. So it'll be 5 times 4 times 7 factorial. And if you put into a calculator, it'll get us 100,800 right here. Then we have number 3, sorry. So the word history, how many ways are there to arrange the word? So let's look at how many words there are in history, the word. There's 7 words. So basically the amount of ways to arrange the word will be 7 factorial, which is equal to 5040. Right, like so. And number 2, arrange when O and R are together. So let's just use examples just now. So let's say the 7 words, it will be 7 blocks. 1, 2, 3, 4, 5, 6, 7. Oops, and 7. So O and R have to be together. So let's just group them together. O and R. Let's just put O and R. And since O and R can rearrange by themselves, so you do 2 factorial because it could be OR or RO. And it would really matter because RO is not the same as OR in terms of like the whole word and the whole meaning. And because O and R have to be together and it's not that it has to be in the front or in a certain position, that means that you have to like arrange it along with other letters. So what I mean is that OR could be, in this case, it could be like this, or it could be like this. It could be in this position right here, or it could be in this position right here. So you don't know which position it is in. So you have to permute, or like you have to like rearrange it with other letters. So just count how many blocks there are left. It'll be 1, 2, 3, 4, 5, and OR is OR together. They combine together to form a big block. So it'll be the 6th block because you can't separate O and R together. And remember from the basic counting principle, to arrange 6 people or like 6 blocks on a line, you do 6 factorial. So basically you will have to times by 6 factorial. So it'll be 2 factorial times 6 factorial. And if you put into the calculator 2 factorial, which is 2 times 6 factorial, we get 1440. So 1440 right here. And number 3, where O and R are not together. So what you could do is that you could like just draw 1, 2, 3, 4, 5, 6, 7. You could find like all the ways when O and R are not together. It could be like OR, OR, R are like different, like OR, blah 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 blah. But it would take way too long. So one really nice trick is that you can use the total number, the total arrangement for the letter, which is part A, 5040, minus the amount of times when O and R are together, which is part B, 1440. And if you have the total number of arrangement, take away the times when they are together, that means that you can find the times when they are not together, which is what you're trying to find, which is equal to 3600. And it's a nice trick to know. And then we have some more examples. How many ways 3 prefects can be appointed from 10 candidates? So what you can do is that you can just think of, if like, let's say if you have 3 candidates, 3 right here, 3, would A, B, and C be the same as B, A, and C? And the answer is yes, because there are still 3 that are elected and they are the same, like same people. If you just rearrange them around, doesn't really matter the arrangement. So in this case, it's combination. It'll be C. So to appoint 3 candidates from 10 candidates, it'll be 10 C3. And if you put into your calculator or if you simplify it, you'll get a value of 120. And we'll move on to the next question. I want 4 t-shirts and 2 polo shirts. How many ways to arrange if I have 10 t-shirts and 4 polo shirts? So let's just think of it this way. We want 4 t-shirts and 2 polo shirts. Let's just take the polo shirts for example. The polo. Let's say when you have polo A and polo B selected. Will polo A and polo B being selected the same as polo B and polo A being selected? And it is the same, because you still have both of the t-shirt and the order doesn't really matter when you pick it out because you still have both of those polo. So in this case, it will be combinations as well. So when we have 10 t-shirts and we want 4 t-shirts, you do 10 C4 times by, because they are the same, like they happen to be in the same group because it's not like different elements. They have to be in the same because you're trying to find how they're the relationship affect each other. And there'll be 4 polo shirts, so it'll be 4 C2. And if you put into a calculator 10 C4, let's just put it 10 C4, it'll be 210, and 210 times 4 C2, it will get us 1260. That's the answer. And now we move on to a new question. So 4 of the letters in Mexico are selected. Find when there's no restriction. So it says, so this question basically just asks if it's selected, not like if it's like arranged in the line. So Mexico has 6 letters. So 4 are selected. So if you were to select 4, would MEXI be the same as EMXI if you were to just select them so that you have the letters? And it would be the same, because you will still have these 4 letters if you take that in the order of MEXI and in the order of EMXI. And it's not like they have to rearrange in like a letter form or like in a line in this case. So it just have to be selected, and they're the same. So it will just be 6 C4, which is, if you put into a calculator, it will be 15. Right, so number 2, M has to be selected. So from the 4 letters right here, M is reserved. And so just put the first block for M and then just don't look at it. So there are 5 letters left. And 5 letters can be selected and put into 3 slots. So it will be 5C3. And just select it, just to be sure, select it. And therefore the answer is just 5C3. And if you put into a calculator 5C3 will just get us 10. Like so. Then lastly, we have the last question. A committee of 5 members to be selected from 6 seniors and 4 juniors. Find if there's no restriction. So to know that there's no restriction, we know that we can just combine seniors and juniors together to become 10 people in total. And we know that the order doesn't matter, because if we have, let's say, person A and person B being selected, it'll be the same as person B and person A being selected. So it'll be 10 C5, which get us 252. Then we have B has 3 seniors. So let's just draw the line out again. 1, 2, 3, 4, 5, like so. So 3 has to be seniors. So let's just reserve this for seniors, and this is for juniors. So there are 6 seniors in total. So that means we have 6 in total, and they have to be fitted into 3 different slots. So it will be 6C3, because person A and person B and person C will be the same as person B, A and C. This will be times by the junior. There are 4 juniors, and they can be fitted into 2 different slots, times 4C2. So the answer will be 6C3 times 4C2. And if you put into a calculator 6C3 times 4C2, you get 120. Like so, 120. And C has at least 1 junior. So you can just do the way where you have 1 junior plus 2 junior plus 3 junior plus 4 junior. But in the other way, you can just find when you can just use the just now, find the total number of like the combination or like no restriction, which is 252 from the start, minus when there's no junior. So let's just find when there's no junior. 1, 2, 3, 4, 5. So when there's no junior, there will just be 6 seniors. So 6 C5. So 252 minus 6 C5. And then 6 C5 is basically 6. So 252 minus 6. And that will give us 246. And that's the final answer. And that's it for this rules and examples for permutations and combinations. And this video is really confusing because when I first learned this concept, it's really confusing for me. So what I did was that I just did questions and examples and answers and look at the answers to check if I'm correct and to use the right principle for each question. So if you have any question or any like confusion, just drop that in the comment section. And don't forget to leave a like, subscribe, and ring the notification bell so that you don't miss out on any future videos. And as I mentioned, if you have any comments or constructive feedback on my channel or my YouTube or my website, just drop that in the comment section and I'll reply to them. And you can also email me if you have any questions or any questions that you want me to do, and I'll reply to you. And also check my social medias in the description, for example LinkedIn or Instagram for more daily content. And if you need any learning resources or any teaching resources, just check it out in my website, or you can type it out in your browser at www.MakesItEasy.com. And I hope you'll find it useful and helpful, and I'll see you all in the next video, which will be questions for permutations and combinations. But until then, stay safe and happy learning.